Welcome back to my channel, Chemmuneeb. So today we shall start the new paper of 2025, May, June, and paper 1, second variant. So without wasting a time, let's start with it. The first question states, consider the following statement: silicon dioxide has a higher melting point than sulfur dioxide and ammonia has a higher boiling point than phosphine, pH 3. Which statements are correct? So here we have to select the right option by considering the validity of these two statements. So we can see here that SiO2 is a giant covalent compound and sulfur dioxide, on the other hand, is a simple molecular structure. So here we do say that being a giant covalent structure has a higher melting point as compared to the molecular compound of SiO2. It is a simple molecular. And then second statement, ammonia has a higher boiling point than phosphine. So here ammonia is NH3 and phosphine, as we know, is pH 3. Now what's the reason of finding the high boiling point among these two? So basically we do know the presence of the hydrogen bonding as the strongest intermolecular forces within the ammonia molecule. So hydrogen bonding are present in ammonia, whereas pH 3 does not contain the hydrogen bonding. So not just hydrogen bonding are there in ammonia. In fact, we do have ID-ID forces and PD-PD forces, or permanent dipole forces in ammonia. But for phosphine, we can say that since the electronegative value decreases down the group in any group of the periodic table, the electronegativity value decreases down the group. So the difference between phosphorus, the electronegative difference between phosphorus versus hydrogen will be lesser as compared to the electronegative difference between nitrogen versus hydrogen. So in that case, there will be no hydrogen bonding, but definitely there could be presence of PD-PD forces and ID-ID forces and no hydrogen bonding. So phosphine would have less stronger intermolecular forces between its molecules, and that's the reason that ammonia would have a higher boiling point as compared to the pH 3. So both the statements are considered to be correct, which means the correct option becomes option A, which says both statement 1 and statement 2 are correct. That's the answer. Now the next question, number 2. How many neutrons are contained in an atom of iron with a mass number 60? Now, it seems to be a very easy question. We do know that for an atom, we have subatomic particles of proton, neutron, and electron, whereas the mass number is basically the number of proton and neutron combined. In other words, it is the nucleon number, which is an addition of proton plus neutron. And we have to find out the number of neutrons. So simple formula is that we just need to minus the atomic number from the mass number, and the mass number is represented by A, and the number of protons represented by capital Z. That will give you the value for number of neutrons. For iron, the mass number is given as 60. So 60 minus proton number. For this purpose, we need to look at the periodic table. So here in the periodic table, we can see the atomic number is 26. So just take this value from here. 60 minus 26. That will give you an answer of 34. So that's the right answer. 34 is option C. So C is the correct answer. Now next question, number 3. The diagram shows Boltzmann distribution molecular energies. So we have a reaction, gaseous reaction with two different temperatures and two different activation energies for this gaseous reaction, we have to find out the right combination in which there shall be highest reaction rate. So we need to consider the factors behind the higher reaction rate. We know that as we increase the temperature for a gaseous reaction, then it indicates a higher rate of the reaction. That's a direct proportional reaction relation between them. Also, if the activation energy is lesser, if the activation energy is lesser, there shall be a higher rate of the reaction. And how activation energy is lessened? It can be lessened by using the catalyst. It can be lessened by having a greater surface area or greater collision frequency. But the most important is the catalyst. So if we employ the catalyst, use of a catalyst uh, decreases the activation energy by providing an alternative pathway that increases the rate of the reaction. So here now we have two curves now. We do remember from the literature, and that is when temperature is increased, then as a result of this, the Boltzmann curve will shift towards the right and lower position. The peak of the curve will shift towards the right and it will be shifted towards the right position. That is when the temperature is higher. Now we can now use this theory here. Here T1 indicates the peak which is at a higher position, and T2 indicates the peak which is at lower and towards the right. It is lower and towards the right of the T1. It is decreased and moved towards the right side. This indicates that T2 will definitely higher temperature as compared to T1. Now look at the activation energy. We can clearly see that on the x-axis the energy is increasing towards the right side, which means that activation energy of the second condition will be of higher activation energy as compared to the first activation energy, which is on the left side. So EA1 is smaller than activation energy of the second condition. So we do need smaller activation energy for the higher rate of the reaction, and we need a higher temperature. Why rate of reaction increased by higher temperature? Because of the uh, effective collision frequency increases. Effective collision frequency increases at a high temperature. So both of these factors increases the rate of the reaction. Okay, now we will see that we need a higher temperature, that is T2. So T2 is present in option C and in option D, and we need a smaller activation energy. Yes, as I said before, that the catalyst provides an alternative pathway with smaller activation energy to increase the rate of reaction. So EA1 is present in option A and then in option D. So there are two ticks in the option D. That's why the correct option becomes option D. Now, question number 4. The reaction between sulfur dioxide and oxygen has the equation given. Okay, this is the equation along with enthalpy value, that is minus 197 kilojoule per mole. And then we have 1 mole of SO2, 1 mole of O2, which were initially present in the closed container. And when the equilibrium was established, then 0.8 mole of SO3, that's SO3, sorry for the um, less readability since this is the only version available right now. So this is basically SO3 at present and the equilibrium mixture. Which statement is correct? So we have to verify each and every statement to find out the correct answer. Although some of the statements are already marked to be crossed, but we can verify these statements to be incorrect. So first statement says the equilibrium partial pressure of SO2 is greater than the equilibrium partial pressure of O2. Now, how do we know that? Basically, the partial pressure is basically related with the mole fraction. The equation or the formula is partial pressure of any substance. Let's suppose if it is the partial pressure of a substance, then it is equivalent to mole fraction of A multiplied by total pressure. Now this is the formula which we use. So mole fraction on the other hand is basically the number of moles of the substance A divided by total number of moles of all the gaseous substances present in the mixture multiplied by total pressure. Okay, so for those substances which have the higher value of the number of moles of that substance, then definitely that will have a higher partial pressure. So partial pressure is related directly with the number of moles. So for this purpose, we need to construct the expression for this by using the values provided. So let's say we have 1 mole of SO2 initially. So I'm just going to write here initial as I and I. So 1 mole of SO2 was there, and then 1 mole of O2 was there, and in the initial state there were no moles of SO3 produced. So this is 0. But after some time, there were 0.8 mole of SO3 produced. So I will write 0.8 over here. This is when equilibrium was achieved. So if it is 0.8 mole of SO3 produced, then we need to calculate the number of moles of the SO2 produced at the same equilibrium stage. For this purpose, just look at ratio, uh, the ratio of the moles. There are 2 moles of SO2 and there are 2 moles of SO3, which means they are 1 to 1. They are equimolar, which means that if 0.8 moles were produced for SO3, then it means we need to minus this value from the initial value of the SO2. So 1 minus 0.8. Now that will give me 0.2 mole. So 0.2 mole were present in the equilibrium state of the reaction for SO2. Now similarly we need to calculate for O2. But here O2 is present by 1 mole. So if it is 1 mole and SO3 is 2 mole, which means that the 0.8 should be halved. The 0.8 is basically the value for the SO3 produced, and 0.8 divided by 2 is equal to 0.4 is the number of moles of O2 which were basically reacted, since it is 1 mole. So I need to find the equimolar amount, the equilibrium, the value at equilibrium stage for this O2. So it will be like this: 1 minus 0.4 is equal to 0.6. So 0.6 is the number of moles of O2 that was present in the equilibrium stage. Now we have all the values: 0.8, 0.6 and 0.2. These are all the values at equilibrium stage of the reaction. Now we check these statements. The first statement says the equilibrium partial pressure of SO2 is greater than the equilibrium partial pressure of O2. As I told you before, that the partial pressure is related with the mole fraction, and it is also related with the ratio of moles divided by total number of moles. Now here the SO2 has 0.2 moles over here, whereas the O2 has moles of 0.6. So 0.2 mole is smaller value as compared to 0.6. That means that the equilibrium partial pressure of SO2 would not be greater, it will be lesser. So it should be written as lesser, then it will be the right statement. So 0.2 is the mole, and that is also related with the pressure, as we already familiar with the relation that 1 mole has a volume or pressure of 1 atm for any gas. uh, so uh, if the mole is less, then definitely the pressure will be less. So that's why A is the incorrect option. The B option says Kp has units of mole per dm cube. Now, for this purpose, we need to uh, find out the expression. So I will write the expression here. Kp is equal to concentration, partial pressure of SO3 with scare on it, since it is present by 2 moles, divided by partial pressure of SO2 with scare on it, multiplied by partial pressure of O2. Now, if we put their units, that is basically okay. Now here it is mentioning the Kp has units of mole per dm cube. First of all, the thing is that they are all present by gaseous state, so they should be mentioned in terms of the pascals or kilopascals. So I should have or uh, atm as well, pascal uh, on the numerator side and pascal square in the denominator into pascal. So all of this should be mentioned like this. But even if it is a mistake, let's suppose, and they consider that this should be the final answer, I can also find the right unit. So Pascal of the numerator will be cancelled with the Pascal square of the denominator, and we'll be left with only Pascal in the denominator, which means 1/hour Pascal. That should give me Pascal inverse. Let's suppose if it is the mole per dm cube, then it should be mole per dm cube with power -1. That becomes dm cube mole inverse. So in both ways, it is not the right unit, dm cube mole inverse or Pascal inverse. So that's why B is incorrect. C says at a lower temperature, the equilibrium amount of SO3 is lower than 0.8 mole. Okay, the lower temperature is basically related with the enthalpy. We can see here that enthalpy is negative, and we know that it is an exothermic reaction. So if the temperature is lowered, then the equilibrium shift will be towards the left side. So whereas for the endothermic reaction, we know that if the reaction is endothermic and we increase the temperature, then equilibrium will shift towards the right side. So that's how we relate this. So temperature is lowered, reaction is exothermic. Wait, temperature is lower, reaction exothermic. It should move towards the right side. Yes, it moves toward the right side. Since it is exothermic, temperature is lowered. It is similar to the endothermic with higher temperature, equilibrium shift to the right side. So in both ways, there will be a shift towards the equilibrium shift towards the right side. Now, if the equilibrium shift is towards the right side, then the amount of the SO3 at equilibrium stage should be greater than 0.8. So 0.8 value should also be increased if the temperature is lowered. So the C says that equilibrium amount is lower than 0.8, so that becomes wrong. It should be greater than 0.8 because at lower temperature it is moving towards the right side for to produce more and more SO3. So the amount should also be increased. So that's why C is incorrect. The D option says the mole fraction of SO2 is less than 0.8. Okay, now mole fraction, as I told you before, that mole fraction is represented by the number of moles divided by total number of the moles. Now here it is referring to the SO3. Now for SO3, I will write the number of moles of SO3 in the numerator divided by the number of moles of SO3 plus all the substances present in the mixture. So here we have O2, we have SO2. So I will write the number of moles of SO2 plus number of moles of O2. So value should be, we'll substitute the values here. For SO3, I have 0.8, again 0.8 in denominator, plus For SO2, the value was 0.2 in the equilibrium state. So 0.2 plus for O2, it is 0.6. So it should be 0.8 divided by 1.4. 1. So it is 1.6. Now if you calculate the value, it would come out to be 0.5. So 0.5 is a mole fraction of SO3, 0.5 of SO3, whereas it's however, and yes, it also says less than 0.8. It means the same thing. Since the answer was 0.5, that is definitely less than 0.8. So that's why D is the correct option. Now next question, number 5. So before going into this question in detail, I need okay, so first we do the question. Red lead is a red pigment with the formula Pb3O4. Every formula unit of red lead is the same. Okay, so here each formula unit contains 3 lead ions and 4 oxide ions. Lead has 2 different oxidation states in red lead. What are the oxidation states of lead in red lead? So here for this compound lead oxide, there are 3 atoms of lead and 4 oxygen of O. So we need to find which oxygen state will be there on the lead. So for this purpose, I will show you my notes in which we have already covered such type of the question. Okay, here this is a page from my AS chemistry notes. And in this page, you can see an example of Fe3O4, where we saw that when there is a case that there are 3 atoms, then which will be the right oxygen state? It could be one of these two. You can either choose this option, that is also the decimal answer or fraction answer of 1 atom of iron, or you could have the whole number values for 2 different oxidation states. We could have iron with +2 and 2 irons with +3 oxidation states on them. So it will be like this: +2, +3, +3 to give an answer of equal to +8. That +8 will be equal to the -8 of the oxygen. So it is -2 times 4 to give -8. So -8 will be cancelled with +8. You can have access to these notes from my Google Drive access. I have been teaching in an academy where we basically create the Google Drive resource pack for all the O levels and A levels. Since you're watching an AS video, so you can see that these are the folders of all the chapters, and you can for any of the chapter, let me show you. For example, if it's chemical and energetics chapter, you will find these 4 folders. Within the first recorded lesson folder, you find the lecture which I have been teaching in the academy. That includes lecture delivery as well as the past paper practice and all the question answer sessions. So this is how the teaching is done on the higher energy in the academy, and it is a large screen of touch screen. It is a large touch screen on which I have been teaching. So basically, you can have an access to these lessons. And then you will also get the access to the notes, the same notes which I have been using for these past paper practice. So these will include the notes here. So here, these are the notes of all the chapters which you will find in all the folders of the chapters. You can read through these notes and you can watch the lectures, and also you can find the topical worksheets. Uh, they are paper 1 worksheets, paper 2 worksheets, and also solved worksheet of some selective questions which are mostly the numerical based questions, or those questions which require calculations. So calculation based questions, and also questions of the organic chemistry, which are structure based questions. So you can have an access to all of these resource pack for every chapter if you want. So for this purpose, you need to reach me out. So their notes are there, the topical worksheets which are solved as well as unsolved. This is the front page of my topical worksheet, which are already published in the market with my name. You can find them in the image photocopy shop, which are located in these 4 different locations in Afton, Islamabad, PWD Islamabad, Sadr Rawalpindi, Barrytown, and you will find all the solved questions and unsolved questions in them. Now coming back to the topic. So in this case, there are 3 lead atoms and 4 oxygen atoms. So for oxygen atom, we will again have -8 oxygen state, -2 for 1 atom, times 4 to give us -8. To balance this -8, we should have +8 on lead atom. So how do we get +8? We can have different combinations. We cannot get combinations from +1 and +2. Let's specify, right? +1, +1, +2, that would give me +4. If I write +1, +2, +2, that would give me +5. So I cannot have this combination. And I need to have only 3 combination because I have only 3 atoms of lead. Now B option says +1, +1, +3, that is +5, +1, +3, +3, that is +7. Now +2, +2, +4, that is +8. That is the correct option. And if I write +2, +4, +4, that is +10. That is incorrect. And +2, +6, +6 is already exceeding +8. +2, +2, +6, that is also exceeding 8. So the only correct option is the C option. And now question number 6. Some standard enthalpy of combustion that are given, and this is the table provided. And in this table, we are given the values of enthalpy of combustion. We have to find the enthalpy change of formation of methanol. Okay, so for this case, I need to draw the Hess cycle only to get the right answer. So here, carbon is basically reacting with hydrogen along with oxygen to make the methanol, and we should know the formula of methanol is already provided, CH3OH. So it will be like this, CH3OH. Now it is since enthalpy of combustion value, so I will put arrows like this: enthalpy combustion for carbon and enthalpy combustion for hydrogen, and then enthalpy combustion of methanol. These would give me CO2 plus H2O. These are the combustion products for this case. Now I will put the values. The enthalpy combustion of, okay, and now the next step is to balance the number of elements other than oxygen, because For combustion, the oxygen used is excess. So excess oxygen does not need to be balanced. So we are left with only carbon and hydrogen. The carbon atoms are balanced in all the 3 points, but hydrogen is 2 here, whereas it is 4 here. So I will put 2 moles of hydrogen over here. To balance hydrogen over here, I will put 2 over here. So 2 moles of hydrogen produce 2 moles of water. Now I will put the values. For carbon, the value was minus 394. Hydrogen is minus 286 for 1 mole. So it should be multiplied with 2. And the methanol value is minus 726. Now for this type of the half cycle, okay, now the value to be calculated is enthalpy change of formation of methanol, which is this X. I will write X here. You can use any letter here. Okay, so here the vector addition rule is applied here. Vector addition rule for head to tail rule addition. So it means X plus minus 726 is equal to these two arrows. If I say it as arrow A, this is arrow B, so it will be equal to arrow A plus arrow B. So this is how we do the vector addition. I can also put this as arrow C, so you can say X plus C is equal to A plus B. Now I need to find the value of X. X will be simply equal to A plus B minus C. Now I will use the values here. X is now added to 726. So X plus minus 726 or the other simple way to use the formula is enthalpy is equal to reactants minus products. That's another way. So reactants are these ones and these are the products. So you can also use this formula. So I'm gonna use the right way of a cycle. So x plus minus 7 to x is equal to a plus b, and as I told you before, is it could be carbon and hydrogen combined. So minus 394 plus minus 2 times of the minus 286. 2 times of the minus 286. So x will be equal to minus 394. This will be equal to minus 572. Minus 572. And this will go to the right side to become plus 726. So when you calculate these values, it will be, the answer will be minus 240. So minus 240 is a correct answer. That's why A is a correct option. Now question number 7. Which row is correct? Okay, so here we need to find the correct bond angles for all the compounds, and then we will find the right answer. Okay, so if you remember the literature, the angle of H2O was 104.5 degree. For BF3 it was 120 degree. Since there are only 3 bonding pairs, for this it has 2 bonding pairs and 2 lone pairs. For BF3 we have 3 bonding pairs. For ammonia we have 1 lone pair plus 3 bonding pairs, and H2O is same. So 120 angle for BF3, and for ammonia we had 107 degree. For water it is similarly 104.5 degree. Now largest bond angle, put the same value, say 120, 10.5, 120, and 107. Now smallest angle should go for water, so it has smallest angle between atoms, and largest angle should go towards 120. So the only correct you do not need the central column to find out the answer, since the only correct combination is option A, in which H2 have 104 as the smallest bond angle and BF3 is the one with the largest bond angle. So A is the correct option. Now, question number 8. In the Haber process, the reaction between the two gaseous reactants requires the use of a catalyst and that contains the transition element. Which is the metal and what is the mole ratio do the gases react in which mole ratio? So it is referring to the Haber process. So you should remember the equation N2 plus 3H2 to make 2NH3. Now this is the Haber reaction. It is basically the equilibrium reaction. And this happens in the presence of the catalyst iron, whereas vanadium is used in contact process during the sulfuric acid formation. Vanadium. So C and D are correct, incorrect, and the ratio, mole ratio of the gases which react. So these are the reactants which are reacting with each other. So we have 1:3. So 1:3 are the correct. So the only correct option is the B option. Now the question number 9. So before going into question number 9, I would like to share something with you. This is the resource pack on Google Drive, which I have been uploading for Iodochemistry, AS level, and IGCSE. So for example, if it is your AS level, you can get this whole resource pack in which all these chapters are mentioned. And within these chapters, you can find the 4 furthest subfolders. The folder of recorded lesson includes all the teachings which I have been doing in the academy, and you can watch these lecture videos in your own pace, in your own convenience. So this is how I have been teaching for all the chapters. You can watch that. This is on the smart screen. So last time I was doing so these are all the lectures on all the chapters of the AS chemistry. Sharp vertical increase in the pH value in the vertical section. After the vertical section was, these are all the lectures, and then the next folder you can find the revision notes. Within the revision notes, you can find the lecture notes of all the chapters there. Okay, so these are the lecture notes. So you can find these lecture notes for all the chapters of AS chemistry, physics, which includes the physical chemistry, organic, inorganic, and analytical chemistry. All right, so after this, you can also find the topical worksheets. So among the topical worksheets, you will have the solved topical worksheet of paper 1, and then unsolved topical worksheets of paper 1 and paper 2. So here you will find all the questions which I have compiled from 2012 up to 2023, but the questions are starting from 2012. like this one. And this is a complete resource pack. You can practice all these questions of different chapters, which we call as topical worksheets. And among the solved topical worksheet, you'll find the solved questions as well. Some of the numerical based questions which require calculations, they are already solved there. So this is a file which includes the solved questions. So now this is the first page of the topical worksheet of solved questions. So here, these are the solved questions along with their workings for different numerical based questions, and you can have an access to this file as well. So all the workings are done for the numerical based questions. And then at the last, you will also find the test sessions for those students who are already registered. They will go through frequent tests after every chapter. So this is all about the topical resource, and this is all about the resource bank. Now question number 9. Aqueous hydrogen peroxide H2O2 decomposes into water and oxygen in the presence of a suitable catalyst, and this is the volume and concentration of the hydrogen peroxide, and this is the volume of oxygen which is produced in 2 minutes. The volume of the gas was measured at room conditions. What is the average rate of decomposition of hydrogen peroxide during this 2-minute period? Okay, so here we have to find the rate of the decomposition. So first of all, we need to construct the chemical equation in which there is a decomposition of H2O2. So H2O2 will decompose to make water and oxygen. Now to balance this equation, I need to put 2 over here and then 2 over here. So hydrogens are balanced and oxygen atoms are balanced. Now this is the volume and concentration of H2O2. So we'll calculate the moles of H2O2 from this given information of hydrogen peroxide. This will give me 0.50 times 0.5 divided by 1000. So this is equal to 0.025. So 0.025 is a mole for the H2O2. And similarly, to calculate the moles of oxygen, I need to use like molar volume formula here. So moles will be 120 over 24,000. Now this value will come out to be 0.005 mole. Zero point double zero five mole. Now we can see here that 0.025 mole were present for a hydrogen peroxide and 0.005 mole were present for oxygen. But here the moles of oxygen in balanced equation are 1, and for H2O2 there are 2 moles. So we will divide this by 2 to see the difference, to compare easily which one is a limiting and which one is an excess. So 0.025 divided by 2 gives me 0.005 1 to 5 mole. Now, if I compare this is greater value and this one is smaller value, which indicates that H2O2 is the one which is in excess amount and O2 is the limiting one. This is limiting reactant. So it means that the amount of H2O2 needs to be found by doing the ratio method between the O2 and H2O2. So O2 ratio H2O2. The O2 was present by 1 mole, H2O2 was present by 2 moles, and O2 moles were 0.005, and H2O2 will become X. So X value is basically 2 times of 0.005. This is equal to 0.01 mole. So this is the mole of the H2O2 that reacted, since O2 was the limiting one. Okay, I have calculated the value of mole of H2O2 which reacted, but I need to check the rate of decomposition. So rate of decomposition were given in terms of mole per dm cube. In all of these options, I can see that the unit is mole per dm cube. That means that I have to write rate is equal to concentration divided by time. Now the concentration is basically, in this case, is mole divided by volume divided by time. So mole in H2O2, since we are going to refer to H2O2, so mole in this case will be 0.01 mole. The volume is used taken from here, but the volume is in cm cube. So I have to divide this cm cube with 1000. So this gives me 0.05 dm cube. So I will put 0.05 dm cube. Divided by time, time is shown to be 2 minutes. So 2 minutes must be converted into seconds. So 2 into 60. This is 120 seconds. So divided by 120. So when you do the calculation, it is simply like 0.01 divided by 0.05 into 120. This is equal to 0.00166 and then 667, which is basically equal to 0.0017. So that's why the correct option becomes the option number C. Now the next question, number 10. The average intermolecular forces in water are much stronger than the average intermolecular force in steam, and then average intermolecular force in ice are slightly stronger than average intermolecular force in water. We are given two enthalpy processes, and then we have to select the right option. Okay, so here we can see that the water is being converted from liquid to gas. Though the enthalpy change associated with it is vaporization in way, which means conversion from liquid to gas, or you can also consider as the boiling enthalpy in a sense, because it again means converging from liquid to gas. The other enthalpy is from solid to liquid, that is basically enthalpy related to melting. M stand for melting here. Okay, so the value assigned here are in terms of theoretical way that intermolecular forces in water are much stronger than average intermolecular force in steam, which means the enthalpy required in first equation must be very much greater, since it requires a lot of heat to break down the stronger intermolecular forces in the water as compared to the gas. But if we can convert the ice into the liquid, then it does not require much stronger forces since it is slightly stronger. So I've just put one symbol here. Now we have to decide which statements are correct. The first statement says that delta HD and delta HM are both negative. So the negative means it should be considered as exo, but no, it is not exothermic reaction since we are melting the compound and we are boiling. For that purpose, we require to give heat. A heat is being given to the system to convert from to melt it or boil it, which means it is basically the endothermic process because we are providing the heat. So that's why it is not exo. So one becomes incorrect. The second statement reads delta HT is greater than delta HM. So yes, delta HT required a lot of heat to break down the forces and convert into the gaseous form. So it is the right statement. And the third statement, the intermolecular forces in ice and water are of the same type. Now, they are the same type only if we consider that the forces were slightly stronger. So slightly stronger could be very, very small value. So that's the reason that very small enthalpy change is required here. So that is associated with the presence of the intermolecular forces in the compound. So since the intermolecular forces are of the same type, that's why very slight enthalpy change was required there. Or intermolecular forces were slightly stronger. So third statement is also correct. In this case, second and third statement are correct, which means the correct option becomes option D. An experiment is carried out to determine the value of X in hydrated lithium hydroxide, and this is a compound of the hydrated compound. A sample of the solid. A sample solid is heated in a crucible over Bunsen flame. Complete dehydration takes place, decomposition does not occur. So here we are given the values in terms of the variables. The empty crucible value is considered to be Q, and the mass of crucible along with the hydrated compound is considered to be R. Then what is the mass of crucible and residue after heating is S. We have to determine the value of X, which indicates the number of water molecules bonded through chemical bonds with the lithium hydroxide. Now we have to decide which of these is the correct answer. Now for this purpose, we should go back to the literature in which we had similar type of the question to determine the number of the water molecules chemically bonded with the ionic compound. So I'm going to show you the page of the notes. All right, here's the page from my notes of AS Chemistry. Here you can find one such relevant question in which we were supposed to find the uh, number of water molecules present with this copper sulfate. So initially they had this mass of the copper sulfate hydrated, and when it was heated, the mass was this. They took the difference to find the mass, which is the mass of the which is the mass of the water. This is the mass of the water produced by taking the subtraction. But the mass which was reduced is the mass of the anhydrous compound. So 4 gram is basically the mass of the anhydrous, and 2.25 is the mass of the water. So they use these values to find their moles. So moles of copper sulfate will be 4 divided by 1 molecular formula of CuSO4, which is 159.6. CSO4. Similarly, the MR of water is 18. So moles is calculated separately for water as well as for the copper sulfate. Then they take the ratio of water to the anhydrous compound. So this is the ratio. Water to copper sulfate ratio gives this value, and this is 4.98, which is rounded off to 5. So 5 is the value of X in this case. Now we refer to the similar literature to our question. You can have an access of these notes by letting me know in comment section, or reach me out on my WhatsApp number as provided over here, or it's also provided in the WhatsApp in the comment section and description section. Now moving back to the question, here we have to consider what these R minus S and S minus R indicate. Okay, now first of all, the S is indicating the mass of crucible and residue after heating, and R indicates the mass of crucible with the hydrated compound. So when we take R minus S, then R minus S is basically giving you the mass of H2O. This is the mass of the H2O because we are subtracting the mass of the anhydrous from the hydrated compound. So R minus S will give you the mass of the water, and then the mass of the anhydrous. What is the mass of the anhydrous? For this purpose, you will subtract the value of Q from S, because Q is giving you the mass of only crucible, and S was carrying the mass of both crucible along with the residue. So S minus Q is basically the mass of, I will say, anhydrous LiOH. LiOH. All right, so here we have calculated the we have taken the values in these forms. Now, in that question, we saw that there was basically the ratio between water. There was a ratio between water to the LiOH. That was a ratio between them. Similarly, we'll do the ratio over here. Now, the ratio should be with respect to the moles as well. So for H2O, the moles will be calculated to be R minus S divided by the mass of water, which is 18, ratio LiOH, again in terms of its moles. So mass of LiOH was taken out to be S minus Q divided by its MR value, which is 23.9. We can check like this. The mass of Li from the periodic table gives 6.9. This is the mass, 6.9. And 6.9 plus 16 plus 1. Now this will give you 23.9. Now 23.9 come over here. Now we have to rearrange the equation, since this ratio means it is being divided. So R minus S divided by 18, and this S minus Q will be multiplied S minus Q, and this 23.9 will come to the numerator, since it is a division of the division, or it is a divider of the divider. So it will come over here. 23.9, like this. So this is the expression which we'll get to find the value of the X, or which is basically the water crystallization of water. So this equation belongs to C option. So C is the correct answer. Now the next question, number 12. A sample of an ideal gas occupies a volume 240 cm cube. This temperature, this pressure, how many moles of gas are present in the sample? So simple formula is used here, which we know is PV is equal to nRT. We rearrange this equation to find N, which will become RT, which will be N is equal to PV over RT. Now, pressure in this case is in the units of kilopascal. If we have pressure in kilopascal, then the volume unit should be dm cube. And the pressure, if the pressure is in pascal, then the volume unit should be meter cube. So I'm not going to change the units of kilopascal, but I need to convert this cm cube into dm cube. This will become, if we divide this 1000, you will get 0.24 dm cube. And this temperature must be converted into Kelvin. So 37 plus 273 will give me 310 Kelvin. Okay, now apply the substitute the values here. 100 kilopascal into volume is 0.24 dm cube. R is general gas constant, which is a constant value of 8.31, and temperature is 310 Kelvin. When you calculate the values, you will get 9.32. If you round off it, you will get this answer as 9.32 and 10 raised to the power minus 3, which is the option B. Now question number 13. Under certain conditions, CCl4 and water are react as shown. The activation energy is given, which is plus 62 kilojoule per mole. And this is the equation along with its enthalpy value minus 61.5 kilojoule per mole. Which enthalpy profile diagram best fits this reaction? Okay, now here we have to decide the right diagram for this particular reaction. So first of all, we can see from the value of enthalpy that it is a negative sign, which indicates that it is an exothermic reaction. So which of these equations are of exothermic? You know that in case of the exothermic reaction, the product sides are at the lower position as compared to the reactants. So we can find lower position of the product in the option A and also in the option D. Both of these options indicate that products are at a lower position. Then it means that option B and C will be excluded. They are not correct. So option B and C are incorrect. Now we have to decide which of these two is correct, A or D. So we can see that in case of A, the graph for the activation energy, which we know is the difference from the reactants to the top of the peak. This difference is we know as activation energy difference. And from reactants to the products, that difference is basically of the from reactants to the product, that is for enthalpy. Now in case of A, the difference, the activation energy value is so small, but definitely enthalpy value is greater. It is a higher value. Whereas in case of D, the activation energy has a considerably higher activation energy, and enthalpy is also a higher value. So which one will be correct? For that purpose, you need to look at the value given in the statement, that is plus 62 is the value of activation energy, and enthalpy value is minus 61.5, which means that both of these values are almost similar. They are almost similar. They're just a difference of 0.5 kilojoule per mole. That is not a large difference. So the similarity of these two values can only be seen in case of the option D, where you can find clearly that the difference of reactant to the top of the peak, this difference to the top of the peak, and this difference from reactant to the product, they are almost of similar magnitude or similar heights. That means this is the right option, having almost similar values for activation energy and for the enthalpy. So D is the correct answer. Now question number 14. A helium ion contains 2 protons, 2 neutrons, and 1 electron. This helium ion and a proton are passed separately through a uniform electric field, and this is a diagram for this movement of particle from electric field. The particles are traveling at the same speed. Which row describes the path of each particle? Okay, so here we have to describe which particle is basically indicated by the lines, which means if this A is basically indicating the helium, or 2 is indicating the proton. So this is how we have to identify which path is basically showing the identity of which particle. Now look at here, we have the helium ion which contains 2 protons. So 2 protons are there, 2 neutrons are there, and there is 1 electron. Now this is the total number of subatomic particles inside of helium ion. H helium plus helium ion. We don't know the actual charge on it right now, but we can say here that if there are 2 protons and there is 1 electron, which means that the overall charge should be 2 positive and 1 negative. That should give you an overall charge of, so it means that helium is positively charged, and then proton, we already know that proton is also positively charged. So both of them are positively charged. So here in this diagram, we can clearly see that the lines which should be moving towards the negative electric field, or you can say the negative plate, should be the right answer. So both fifth and fourth, the fifth path and the fourth path, they are both moving towards the negative plate. That means 5 and 4 are the identities of the helium and proton, but which one is correct? We need to see that. A and B become incorrect because the path number 1 and path number 2, they are moving towards the positive side. So this is not the right options. And now 4 and 5. Okay, now in this case, we need to consider the deviation or the extent of the deflection over here. We see that 5 is deflecting earlier as compared to the path number 4. 5 is moving, is turning. It is turning earlier as compared to the path number 4. We know from the literature that lighter particles are easily deflected or more deflected. Lighter particles are more or easily deflected. So one path is indicating the heavier particle and the other path is indicating the lighter. Okay, now helium has been shown to contain 2 protons, 2 neutrons, and 1 electron, and the total mass should be counted towards the number of proton and neutrons. It is almost equal to 4. whereas proton is just a single subatomic particle. That means helium is heavier as compared to the proton. So the path number 5 should be associated with the proton, and path number 4 should be associated with the helium because on the basis of their masses. So path number 5 is of proton, path number 4 is of helium ion. That means the correct option becomes option number C. Now question number 15. The skeletal formula of arginine and lysine are shown. These are the two structures. We have to select the correct row. All right, so here we are provided. We are provided the empirical formula and MR values, which means that we have to find out the empirical formula of both these compounds as well as the MR value, which is basically related to the molecular formula. MR is associated with the molecular formula, not with the empirical formula. So first, let's start with the arginine. For arginine, I will start with the number of carbon atoms first. So I have 1, 2, 3, 4, 5, and 6. So I have 6 carbon atoms. And then let's see the hydrogen atoms. So hydrogen atoms are 2, and we have 3, 4, 2 over here, 2 over here, 2 over here. Let me read them first to make it clear. There are 2 hydrogen atoms over here, 2 over here, 2 here, and 1 over here. And there's no hydrogen. So total we have 2, 3, 4. These are not 2. Yeah. We have 2, 3, 4, 4 plus 2, 6, 8, 10, 11, and then 2, 13, and then this is 14. We have 14 hydrogen atoms. And then about the nitrogen, 1, 2, 3, 4. So 4 nitrogen atoms. And then oxygen atoms are here, only 2 oxygen atoms. So we have 2 oxygen atoms. The empirical formula means we have to divide all these values by 2. So I will get 3 carbon and 7 hydrogen, 2 nitrogen, and 1 oxygen, which means the empirical formula should be C3H7 and 2O. Okay, now arginine empirical formula is this. Now we have the next compound lysine. So we'll see the number of atoms of different elements again here. So carbon, starting from the carbon, we have 1, 2, 3, 4, 5, and 6. So 6 carbon atoms. And then about the hydrogen atoms, I need to raise that all. We have 2 over here, 4, 6, 8, 10, 1 from here, 11. This is 2 gives 13, and this one 14. So I have 14 hydrogen atoms, 14 hydrogens. And nitrogen, there are 2 nitrogen atoms, and oxygen, we have only 2. So 2 oxygen atoms. Now the empirical formula should again be divided by 2. So 3 carbon plus 7 hydrogen plus 1 nitrogen and 1 oxygen. So empirical formula will be C3H7NO. That's the empirical formula over here. So empirical formula of lysine is this one, since it has 7 hydrogen, whereas the next option had 8. That was incorrect. All right. Now we calculate the MR values. MR value for the actual molecular formula compound. So if you calculate 6 into 12 plus 14 into 1 plus 4 into 14 plus 2 into 16, this will give you 174. So 174 for this one. And if you and then the MR value for the lysine compound, it should be 6 times 12 plus 14 times 1 plus 2 times 14 plus 2 times 16. The answer will be 146. So 146 is over here, but that was already had an incorrect empirical formula. So this incorrect empirical formula doesn't give you the right option D. That means the only correct option becomes A option, which has both the correct empirical formula and the correct molecular mass, MR mass, relative molecular mass of the molecular formula of that compound. Now, question number 16. The oxide and chloride of an element X are separately mixed with water. The two resulting solution have the same effect on litmus. What could be element X? All right, so we have to decide the correct element out of these four to be the right answer. And we have to consider the oxide of these elements as well as the chlorides of the elements. No, which element do we have here? We have aluminium, calcium, sodium, and phosphorus. Out of these four elements, the three elements A, C, and D, which means aluminium, sodium, and phosphorus, they belong to period number third. But the element B, which is the calcium element, it is um, belonging to fourth period. That is present in fourth period. So we will relate the properties of calcium as compared to the properties of the magnesium, which is present in third period. Now I'm going to show you the notes, the literature of the oxide of these elements and the chlorides of these elements inside of water. What kind of pH value do we find there? Because the pH is linked with the effect on the litmus. We know that litmus turns red in acidic condition and it turns blue in the basic condition. So we need to see that the elements must exhibit similar type of the acidic or basic property when the oxide or chloride are mixed in the water. Okay, let's go to the notes now. Now this is a page. This is the page of my AS chemistry notes, and you will see all the information here, how the elements of period number 3 are acting. So period 3 elements in the question, we had sodium. We had the sodium element. Now sodium in terms of the oxide will give you a pH value of 14. So I'm going to write 14 in front of it in the question. So we have a pH value of 14 in case of the sodium. When it is oxide, it will produce a very highly basic solution. pH is equal to 14. And what about the other elements? Then the next element was basically calcium, but we have the information about the magnesium. So magnesium is above the calcium. Magnesium is above and calcium is below. If the magnesium is providing pH value of 10 to 11, which means that calcium must have value nearly around 12 to 14. So I'm going to write the pH value in the question. For calcium, it should be having pH value of oxide. When dissolved in water produce hydroxide, pH value will be 12 to 14. And the next element is aluminium. So aluminium does not react or dissolve in water. And so the pH value remains 7. So I'm going to write in front of it for aluminium in terms of its oxide. It is 7. And the last element is phosphorus. Now you can find from this table as well that phosphorus value is 3 to 4. Okay, you can also find in the this paragraph as well 2 to 3 or 2 to 4, both means almost same. So we write for oxide it is 2 to 4. Let's suppose it is 2 to 4. Now we have to also see the pH values for the chlorides of these elements. So let's go back and see the chlorides of these elements. Now starting from the sodium does not react with water. Instead, it is dissolved in water, which means the pH value of sodium chloride will remain 7. So for sodium, it is the chloride value will be 7. Now we can see clearly that it is highly basic. The oxide, when dissolved in water, produce hydroxide of the sodium. That is very strongly alkaline, but the chloride is neutral. So the litmus will have different effects on pH 14 and pH 7. So C is not the correct option. Then next element, magnesium. Since we do not have the magnesium in the given question, but we have calcium, so we can expect that if the magnesium is providing 6.5 in this case, then going down the group in the periodic table, the pH value should become more and more acidic, since we can compare this magnesium with that of the aluminium chloride, which is on the right side of the aluminium, being less basic. If it is less basic and it is providing a pH value of 3, that means that the value of the calcium should lie around 5. It should be around 5 value. So when calcium chloride will be dissolved in water, the value should be around 5. So I will write the value 5 for calcium. It is 5. Now you can see that 12 to 14 is totally alkaline to the area, and pH value 5 is acidic. So they do not have the same effect on the litmus. That's why B is the incorrect. Now let's move to the next element, which is aluminium. The aluminum chloride, when dissolved in water, gives pH value of 3. So I will write 3 for aluminium. So it is 3. When dissolved in water, the aluminum chloride provides pH value of 3. Now 7 is neutral. It is neutral. And 3 is acidic. It is acidic. So they will not have same effect on the litmus. So A is also incorrect, which means we are left with only one element that should be correct one, that is phosphorus. So phosphorus chloride, when dissolved in water, provides pH value of 1 to 2. That is very much acidic. That means its oxide was also providing the acidic area. So 1 to 2 for chloride, they are same. So both acidic will have similar effect on the litmus. So that's why the correct option becomes option D. D is the correct answer. Now, question number 17. Why do the halogens become less volatile as group 17 is descended? By descended, we mean going down the group, descend down. Okay, the first is the halogen bond energy decreases. Basically, halogen bond energy, which is represented as X, representing halogen atom bonded with another halogen atom, that has nothing to do with the volatility. By volatile, we means how easily us the solid or a liquid substance converts into a gaseous form. That is mean volatility. How easily it is converted into the gaseous state. So, um, that is associated with the intermolecular forces. Whereas the halogen bond is basically called covalent bond, is associated with the reactivity of the halogen elements. So we are not deciding the reactivity, we are deciding the intermolecular forces, which means C and D should be referred. The C says the number of electrons in each molecule increases, and D says the van der Waals force between molecules become weaker. So if we go down the group from fluorine, chlorine, bromine, and iodine, we do know that the size increases. And when the size increases, then there will be more electrons in the atom, and more electrons will have an influence on the stronger intermolecular forces, or you can also say the van der Waals forces. So intermolecular forces and van der Waals forces both get stronger going down the group. But here the D option says it becomes weaker. That is incorrect. It should be stronger down the group. So C option says the number of electrons in each molecule increases. So yeah, the number of electrons increases, which means the intermolecular force also increases. Both increase down the group. That's why the correct option becomes C option. Now, question number 18. A compound M is a white solid. It is a chloride of period 3 element. All right, we need to see that the element is of period 3 and it is in the compound form. And information about some reactions starting with compound M is given in the table. So we have these observations of the compound M, which is basically the chloride. The first reaction says compound M plus non-polar solvent gives observation colorless solution, and when compound M added a little to at a time to water, then steamy fumes plus colorless solution. This indicates that there was no particular reaction when it was added to a non-polar solvent. However, there was some sort of reaction when it was added to a water, and we know that water is a polar solvent. So polar solvent does give reaction with the compound M, and it has produced steamy fumes along with colorless solution. That steamy fumes is further tested in the next test when it was reacted with the moist blue litmus paper to give red color. That means that this Q is an acidic fumes. So acidic fumes were produced here, and the compound which is colorless solution was tested with the NaOH in both the few drops and excess NaOH. Now, when it was added to a few drops, it produced white precipitate, and when it was added to an excess NaOH, it was completely dissolved. So we should remember from the literature that the compound, which could only be this one, um, is basically identified using this reaction. If let's suppose if it is phosphorus pentachloride, which is PCl5, then PCl5 does not produce a colorless solution since it has already produced the steamy fumes. We can see from the literature as well that when PCl5 is added into a water, it will only produce acids. So it has only produced acid. So there is no such thing like the colorless solution which must be tested later on. So it should not be PCl5. And about magnesium chloride, let's see about the magnesium chloride. The magnesium chloride says when it's dissolved in water, it does produce a acidic solution only. The acidic solution has a pH of 6.5. Now this is almost very closer to the neutral solution, but there is no such thing like formation of any colorless solution that must be tested further on. It has only produced the HCl, and it is not in the form of the fumes. It is simply the aqueous solution. So aqueous solution of the acid is produced during this reaction. We have this formation of very slight acidic solution here. So it is not the magnesium chloride. About the sodium chloride, it does not react with the water. Instead, it only dissolves in water to produce the sodium ions and the chloride ions. So it is also incorrect. The only correct option is A, because when A is reacting with water, it produces the SiO2, which is a colorless solution, plus HCl fumes that produce the red litmus. And this SiO2 was further tested since it is amphoteric in nature. Sorry, mistake here. And not SiO2, it produces Al2O3. Aluminum chloride produces the Al2O3, which is amphoteric in nature, plus HCl. So HCl was tested later on with the litmus that was verified, and Al2O3 was further reacted with the NaOH. When few drops are used, it produces the salt, and when excess is used, then the aluminum will convert into the initially the salt is NaAlOH4, which is a salt. And when excess is used, and it produces the aluminum hydroxides dissolved completely, plus NaOH, which is also the alkali dissolved completely. So they are dissolved completely when excess NaOH are basically used. So that's why the correct option is the A option. Now question number 19. Which statement about strontium and its compound is correct? Alright, here we have the strontium related to compared with barium. In the first case, so strontium hydroxide is more soluble than barium hydroxide. So for this purpose, we need to look into the literature. What does it say? Now this is a page from my notes, and you can find here that going down the group, the solubility increases. So we had to compare strontium with respect to the element barium. Barium is below strontium, so barium must have greater solubility as compared to the element strontium. So that means that first statement is incorrect, since strontium is less soluble than barium hydroxide. Then option B says strontium sulfate is more soluble than magnesium sulfate. Now we have to see the trend of the solubility of sulfates. So here you can see that the solubility decreases down the group. For group 2 sulfate, it decreases. So strontium is over here, and magnesium is over here. So strontium is less soluble than magnesium sulfate. So it should be less soluble than magnesium sulfate. So B is incorrect. C says strontium nitrate has a lower thermal stability than calcium nitrate. So strontium versus calcium, and that is in the topic of the stability of the nitrates. So stability by the stability trend is similar to the carbonate trend, which means going down the group, the thermal stability becomes smaller as becomes larger. So those elements which are at a lower position, they are more thermally stable. So in the thermal stability increases down the group, which means that strontium must have higher thermal stability as compared to the magnesium nitrate. So we will have the same same concept in terms of the nitrates, since it says that the thermal stability of the group nitrates follow the same trend as that of group 2 carbonates. So thermal stability increases down the group. Here it says strontium nitrate has a lower thermal stability than calcium nitrate. So no, it does not have lower, it has a greater thermal stability than calcium nitrate. So that's why C is incorrect. The D says strontium is stronger reducing agent than magnesium. Okay, now in this case, we should know that these are the metals. So group 2 metals, when participating in the chemical reaction with any reactant, let's suppose the reactant is represented by R, they will react together and the metal will lose the electron to convert into the positively charged ion and reacted with the reactant that should be any negatively charged to make a compound Mr. And within that Mr compound, metal must have +2 charge on it. So it is basically the oxidation of the metal, group 2 metal. And that oxidation means the metal M is reacting as the reducing agent. The one which oxidizes itself acts as the reducing agent. So which should have a good reducing agent? That is related with the size or the ionization energy of the element. So going down the group, ionization energy decreases. In a particular group, ionization energy decreases, which means they are more easily losing the electrons. So strontium is at the bottom, it has least ionization energy, which means it can easily oxidize easily. The one which is easily oxidized means it will be a stronger reducing agent. The one which is easily losing the electron or easily oxidizing is basically acting as a good or stronger reducing agent. So that's why strontium is a stronger reducing agent than magnesium. So that's why the correct option becomes D option. Now question number 20. Sodium bromide is formed with concentrated sulfuric acid. Which row describes the change in the oxidation number of the sulfur and the role of the bromide ion in the reaction? So to find out the correct answer, we need to look into the literature of this topic. So I'm going to show you my AS chemistry notes. All right, here is the notes in which which we covered the reaction of the bromide salt with the sulfuric acid. And when there is a reaction of any salt or the bromide with sulfuric acid, we see the formation of the SO2 over here. Now we know that the oxidation state of the sulfur in this case will be +4, since the oxidation state of oxygen is -4. Now this topic is covered under the topic of the reducing properties of the halide ions. We know that halide ion is basically acting as a reducing agent. So it reduces the sulfuric acid to SO2. Itself, it gets oxidized by to form the H and form the bromine molecule. So bromide ion is acting as a reducing agent and it reduces the sulfur dioxide from +6 to +4. So the change in oxygen number is from +6 to +4. +6 was in H2SO4 and +4 was in SO2. And role of bromide ion is as a reducing agent. So +6 to +4. So the correct option becomes option B. Now question number 21. A reaction occurs when ammonium chloride is added to calcium hydroxide. What is the role of ammonium ions in this reaction? So it is a clear-cut indication that the reaction is between ammonium chloride and calcium hydroxide, which is an alkali, very strong alkali. So ammonium ion, which we know as NH4 plus, it will react with alkali calcium hydroxide, and as a result, there is a formation of ammonia gas. Because this reaction is a test for ammonia and gas formation, or the test for the ammonium salts. This is topic covered under ammonium salts reaction to form the ammonia gas. So anything which is providing the hydrogen ion in a reaction is considered to be an acid. So ammonium ion is basically an acid here. So that's why the correct option becomes A. Now question number 22. Elements Y and Z are both in period 3. Element Y has smallest atomic radius in period 3. There are only two elements in period E that have a lower melting point than Z. So element Y and Z react together to form compound R. We have to find out the compound R from the given options. Alright, here we need to apply the concepts of the atomic radius as well as the concept of the melting points. So for this purpose, I will take you to the notes of AS chemistry, in which we see the trend in terms of the atomic radius and in terms of the melting point. So here are the notes. If you remember the trend in terms of the atomic radius, then you should remember that going across a period from left to right, within any period of the periodic table, the size decreases. So this is the whole this is the trend of the atomic radius. The atomic radius decreases from left to right across a period number 3 or period number 2 or any other period, especially for the normal elements. So this is the trend, and then the trend of the melting points. Now this is the trend of the melting point in terms of the graph, and we can also not this one. This is a trend for the melting point graph. We can, as stated in the question, that there are only two elements in period 3 that have a lower melting point than element Z, which means we can easily find out the identity of the element Z. So here in the notes, we can see that there is graph as well as a table. Within the table, if we consider silicon, let's suppose if we consider silicon, then the elements whose atomic melting point are smaller than silicon, they are all these elements. So there are 7 elements whose melting point is smaller than silicon, which just is used as a reference. But we need to find such element below which we find only 2 elements having their lower melting points. If I take, let's suppose, sulfur, then below the sulfur, which element have the lower melting point? They are argon, chlorine, phosphorus. And if we compare sulfur with sodium, then sulfur is also slower. It's also at lower position. This table indicates very correct values. And that's this graph indicates almost the same pattern, but in the graphical form. So there are almost 4 elements whose melting points are smaller than sulfur. So definitely S is not the one. Now, if I take the phosphorus, as a element, then below phosphorus we find only 2 elements, the chlorine and argon. Chlorine has smaller value, argon has a smaller value, and if we consider sodium, sodium has a larger value as compared to phosphorus, which means this is the element which is present in the compound. So the element Z is basically phosphorus. Now that is found out now. Okay, now we need to see the element Y. Element Y is said to be the smallest atomic, the element with the smallest atomic radius. That means if we go across a period from left to right, the size decreases, and at the extreme right, we have the although we do have the argon, but argon is not included in our list. Moreover, we only take the uh, uh, we only take the van der Waal radius for the argon, since it is a noble gas which does not make bond with any other element. So it will not be considered in our selection. We'll only consider the chlorine to be the one. So chlorine is the smallest element here in its period. So we now have found the other element. The element indicated by element Y is basically the chlorine. So these are the two elements which must be present in our compound phosphorus and chlorine. So we need to see the only compound that can be formed by these two elements is compound PCl3. So the correct answer becomes the option D. Option D has phosphorus and chlorine both. So that is why the correct answer is option D. Now question number 23. 1 gram of each of the four different compounds of group 2 elements are thermally decomposed. The residue in each decomposition is the oxide of the group 2 element. The volume of the gas produced from each reaction is measured at room conditions. Which substance produces the greatest volume of the gas? All right, this question requires lots of calculations. But first, going into the calculations, I will go through some of the resource pack which I am sharing with my students for their online or physical classes. This is the Google Drive folder for the resource pack. This includes the A2 chemistry, the AS level chemistry, and IGCSE. If you are the AS level student, then you can get an access to all the chapters of the AS chemistry, and within each chapter you will find the four different folders. Let's suppose if I open the chapter of the chemical kinetics, then you will find the recorded lessons for this is for every chapter over here. If I open the hydrocarbons, then you find the recorded lessons over here. These are my recorded lessons on the smart screen. And then in the next chapter, in the next folder, sorry, you will find the revision notes. Here, these are the revision notes of every specific and particular chapter. And as there are some, there is also the folder for the topical worksheets, which you can find here. For example, if I open Equilibria, you find three different folders. There is paper 1 topical worksheet, paper 2 topical worksheet, and the solved paper 1 topical worksheets. This is the lecture notes of the chapter number 9, chemical periodicity. And you can see the pages, there are 28 pages. So you can read through these notes, and you can watch the lectures in the recorded lessons, and you can practice these topical worksheets. Also, that the solved topical worksheet contains the solved solutions of those numerical based questions, especially for the physical chemistry. And then at the last chapter is for the test, which is conducted for the students frequently after through some portion of the syllabus. So here is the topical worksheet, which is a solved one. And you can find these workings here. The questions which require solutions or which require some working are shown here. So all of you can get an access. So just leave me a message on my WhatsApp number or reach me out on Instagram or Facebook page, and you can register yourself to get an access for this AS level chemistry or A2 chemistry. And also you can also get the O levels or IGCSE chemistry resource pack. All of these are present and all of them contain more or less similar things. Now, moving back to the question. So for this question, we need to have an idea that this is a mass of all the substances present in the options A to D options, and all of them have similar 1 gram. Okay, now what happens when these compounds are thermally decomposed? We get some products. The products contains the oxide of the group 2 element, also the gas formation. So basically, we need to find the greatest volume of the gas. If you remember the relation that for every 1 mole of any gas, there is a volume of 24 dm cube at room temperature or at room condition. So basically, we need to calculate the number of the moles of the gas produced for all of these 4 different substances when they are thermally decomposed, which means that we need to construct the equations for their thermal decomposition. I can simply write here that if there is a group 2 metal carbonate written as MCO3, it will produce, when thermally decomposed, it will produce metal group 2 metal oxide along with the carbon dioxide formation. And when there is a metal group 2 metal nitrate written as MnO3 twice, because it is a group 2 metal, when it is thermally decomposed, it will produce metal oxide plus 2 moles of NO2 gas plus half mole of the oxygen gas. So this is the balanced chemical equation for the thermal decomposition of group 2 metal nitrate. Now here we have to consider similar for the calcium carbonate, the strontium carbonate, and the nitrates. I will write calcium oxide. I'm just writing the products here. Calcium oxide plus carbon dioxide here. For nitrate, I will write calcium oxide plus I have 2 moles of NO2 plus half mole of O2. For carbonate, strontium carbonate, it is strontium oxide plus carbon dioxide, and nitrate will give me strontium oxide plus 2 moles of NO2 plus half mole of O2. Now it is referring to the gases, which means we have to consider only the gases, which we know are carbon dioxide, nitrogen dioxide, oxygen. These are all the gases here. Okay, now this is done. The next part is that we have to convert the masses of these compounds into their moles. From there we'll find the moles of these gases. Okay, so first of all, we need to convert into the mole, which means we first need the relative molar masses for these compounds. So to make it easier, you should remember that carbonate mass. What is the mass of the carbonate? Since it is CO3, uh, so just write that mass here. The mass of the carbonate part is 60, and then the mass of, you can also check from the calculator, and the mass of the nitrate part is 124. Okay, now add the masses of calcium. Calcium is 40.1, and strontium, you can find the mass from the periodic table. The strontium mass is 87.6. So 87.6. Okay, this is done as well. The next part is write down the molar masses. Now the mass of calcium carbonate will be 100.1. The mass for calcium nitrate is 164.1. 164.1. The mass for strontium carbonate is 147.6. And the mass for strontium nitrate is 211.6. Now I have calculated their masses. Now I need to convert these masses into their moles, which is simply by dividing all these divide one divided by these values. So when I divide 1 divided by 100.1, I should get the mole for the calcium carbonate. So I'm going to rub this off. Now the mass for the mole for calcium carbonate turns out to be 0.00 triple nine. The mole for calcium nitrate is 0.0060 93. The mole for strontium carbonate is 0.00677. Although I'm not taking all the decimal values, I'm just taking some of the decimal values over here. And then for strontium nitrate is 0.004. And 726. Okay, now I have calculated the moles for these substances when I took division 1 divided by their relative molar masses. Now the next part is that you need to calculate the moles for the gases part. So for carbon dioxide, we know that for carbon dioxide is just 1 mole. So the mole of the carbon dioxide will also be according to ratio method, since only 1 mole of carbon dioxide is produced. So the mole of carbon dioxide will also be 0.00999 times 1, since there is just 1 mole. But for the second part, B part, there are 2 moles of nitrogen dioxide and half mole of O2. So I will say it is 2 plus 0.5, since 1 over 2 gives me 0.5. So it shall be 2 plus 0.5 times the number of moles which I have calculated over here. So 0.00693. Now for C part, it is again the carbonate part, so which means this is the same mole, 0.0067751. And then for the D part, I will write I will take 2 moles from the nitrogen dioxide and half mole from the oxygen. So 0.004726 multiplied by 2.5, because I have 2 moles of nitrogen dioxide and half mole of O2. Now when you calculate this, for this part you will get the answer 0.01523 moles for the combined gases of NO2 and O2. And for the D part, you will get 0.011, 0.011, 8 0.15. Okay, I have now the moles of all the four substances in terms of their gases. So it is this mole for the A part. For B part, we have this value. For C part, we have this value. And for D part, we have this value. So when you compare these values, you can clearly see that this is the largest value in terms of mole. This means that this is the overall mole of both gases. So when you multiply this value with 24 dmq, you will get the largest amount of the volume. So the one which has the greatest number of moles will definitely provide you the greatest number of the volume of the gas, which means the correct option becomes the B option. So this is the correct answer. Now question number 24. Sulfur dioxide in the atmosphere can form acid rain, and this happens in two steps. Which row identify the atmospheric catalyst for step 1 and the reagent for step 2? So if you remember that the oxidation from SO2 to SO3 is occurred in the presence of the catalyst of NO2. NO2 acts as a catalyst here, as a homogeneous catalyst. So NO2 is the right option from first column. And then the reagent for the step 2 means you need to convert SO3 into sulfuric acid, H2SO4, and for this purpose, you just need to add water in it. So when you add water, you get H2SO4. So H2O is a correct reagent. So that's why the correct option becomes the C option. Now question number 25. Which statement about the mechanism of an SN1 reaction of halogen alkane is correct? SN1 is that type of the reaction in which the halogen alkane was basically the one in which there were three alkyl chains bonded to the carbon, which was further bonded to the halogen atom, and it went through two steps. The first step involved the breakdown of the carbon halogen bond from the carbocation. The carbocation ion was formed in the first step, and this was the slow step. And in the next step, we had the reaction of the OH ion on the carbocation to make the next organic product, and this was the first step. This was the mechanism for SN1 reaction. So we need to see which of these statements are correct. First statement reads as a nucleophile is substituted by an electrophile. So no. The nucleophile is substituted by another nucleophile, not by the electrophile. So this is incorrect. B says one intermediate is formed from two reacting molecules. So the intermediate is this one. This first was the intermediate, the one which had the carbocation. But this intermediate was not formed by the two reactants. Instead, there was just only one reactant. This is only one reactant over here. So it is not two reacting, it's just one reacting molecule. So B is incorrect. C says the intermediate stabilized by adjacent alkyl groups. So yes. The stability of the carbocation depends upon the number of the alkyl groups bonded to that carbon positively charged carbon. So if there are more alkyl groups, it means it will stabilize that carbocation more. So C considered to be the correct option. But for D, the intermediate is uncharged. So no, the intermediate was definitely charged since we have the positive charge on the carbon. So that is not uncharged, it should be charged. So that's why the correct option becomes the C option. Now question number 26, the repeat unit of a polymer is shown. This is a repeat unit part of the polymer. Three statements are listed. We have to select the right one. Its disposal is hazardous because it produces toxic gases when burned. So this is correct statement since it includes the chlorine atom. So those compounds, those organic compounds which contain the chlorine, they do form the chlorine-containing toxic compounds. And that can also include the HCl fumes as well. So the formation of chlorine-containing toxic compounds is there whenever we have a chlorine element in the polymer. So a part 1 is correct statement. The part 2 states two different monomers are used to make the polymer. So if we look at this structure and if we expect that it is formed by only one monomer containing both the OH and chlorine parts, then it should have a structure like this, that it must have OH bonded through double bond with carbon, and it should have H over here, and then these CH2 like this, and another sorry, it should be have chlorine over here. It should have chlorine over here, and then the next part should have hydrogen. But this doesn't work like this. We do not have the linking of the double bond directly with this part because of the already saturated carbonic atoms over here. These are all already saturated. So it cannot have only one monomer. It must be linked through two different monomers. So those two monomers, which I can write over here, should be the CH, and then we have double bond carbon, chlorine over here, and H. This is one monomer bonded with another monomer which must have the OH group on it. Okay, so these two should be the two monomers which must have been bonding with each other. So two monomers must be there. Now the third statement says that the monomer of this polymer is 3-chlorobutene. Let's draw structure. There must be 4 carbon atoms in a straight chain, and then third carbon must have chlorine on it. The double bond is present between carbon number 2 and carbon number 3, and carbon number 1 has OH on it. Now, if we assume that this is the monomer of this polymer, then we must expect that the linking is between these two carbon atoms with each other in the main chain. This is the main chain or carbon skeleton of the polymer. So it should be linking with these two carbons, and these must then be the side groups on it. So COH should be completely side group on it, which we do not see here. Here this C is the part of the main chain. It is not a part of the side group. Similarly, this chain CH2, it should be considered as a side group here, which again we do not see here since this carbon is present as the main chain. So these should be the side groups only, then we would expect that this should be the monomer of the given polymer. So that's why third is not the correct option. It is not the correct statement. So that's why the correct option becomes the A option. Question number 27 reads, methanoic acid has acidic properties similar to those of other carboxylic acids. In addition, can be oxidized by the same oxidizing agents that are capable of oxidizing aldehyde. So we have to select the pair of the compounds which will give the same observations with phalanx reagent. So if you remember, phalanx solution was that reagent which could oxidize the aldehyde compounds to make red PPT, orange red PPT. That is the confirmatory test for the presence of the aldehyde functional group in the compound. And phalanx solution was a mild oxidizing agent, and it was copper containing compound, and the formation of the red PPT was because of the formation of the copper oxide. So copper oxide compound was formed there. It is Cu2O, and you can see these in the notes here. In my notes, you can see the reaction of the phalanx reagent containing the Cu plus 2 ions complex with the dilute ammonia in the alkaline solution. And this is the result. This is the formation of the uh, this is the formation of the deep blue color due to copper plus 2 ions. So now this is the reaction. Orange red PPT or brick red orange ion is formed, which is of Cu2O. Now this is a reaction. Aldehyde reacting with the copper plus ion in the water to make carboxylic acid, Cu2O, and hydrogen ions. This is the brick red color of the same compound of the product. Now we have to see that which pair of compounds will give result with phalanx reagent. So we know that it is the aldehyde. So in the part A, we have the carboxylic acid on the right side. On the right side we have the carboxylic acid. So this does not give this reaction. The B part is the ester part. So ester will not give this reaction. C contains the ketone. It will not give this reaction. The D option contains the aldehyde on the right side. And we are already familiar that methanoic acid was definitely giving this test because it is similar to those which can be oxidized, similar to the aldehyde. So if aldehyde's property is matching with the methanoic acid, which means in all of these options, methanoic acid was already produced giving the test. But the only D option contains two compounds which can give results just like with the phalanx solution. They give the same results with the phalanx solution. So D is the correct option. Now question number 28. Which row gives pentane nitrile as one product? Pentane nitrile as one product, which means there could be more than one product, but we need to focus on this pentane nitrile. Pentane nitrile will be the structure like this, having 5 carbon atoms like this, and it is bonded with the CN. It will have the 5 carbon atoms, and the last carbon is basically a part of CN. So 1, 2, 3, 4, 5. There are 5 carbon atoms, and the functional group is CN. That is called pentane nitrile. Now, the reaction regions and the conditions for this purpose is basically the halogen alkane reaction is basically in the presence of the ethanol as a solvent, and we use the KCN as a reagent. So this is the correct reaction condition and reagent. So you will use these reagents from the second column. But halogen alkane, here we have 1, 2, 3, 4. There are 4 carbon atoms, but condition is wrong. But the structure is correct. We need 4 carbon atoms because the last part of the bromine will be substituted by the CN. So CN will come over here, which means we will have in total 5 carbon atoms. So 1, 2, 3, 4, 5. There will be 5 carbon atoms when substituted by the CN. So the halogen alkane in option A and B are correct, but reagent conditions are in option B and D are correct. So that's why the correct answer becomes the B option. Now question number 29. An ester R prime CO2 R double prime is hydrolyzed in alkaline conditions. R prime and R double prime are different alkyl groups, which to identify the two products formed. Okay, so product 1, product 2. We know that within the ester, this part is basically written like this, R, C, and this is carbonyl group, and then carbon bonded through single bond with oxygen, and then another R over here. Here they have differentiated these two R on the basis of these signs. I call them prime. Sometimes we call them hat, or we can also call them not. So single prime R is here, double prime R is over here. Now, when it is hydrolyzed in the alkaline condition, then this part will definitely be converted into the alcoholic group. This R is part of alcohol after hydrolysis. On the other hand, the one which is bonded with the carbonyl group, this should become part of the carboxylate ion. It will become carboxylate ion. It will not be carboxylic acid since the condition is alkaline. In the next part, when it reacts with any of the base or any of the salt, it becomes salt or the carboxylic acid. So the part should become RCOO negative. This should be the carboxylate ion over here. So we can select from the given options that the product 2 is basically R double prime. So R double prime is containing OH group. So yes, this is the alcoholic group from R double prime. But R single prime will not convert into carboxylic acid. Instead, it becomes the ion. If I take it closer, this is basically a negative sign over here. It is because of the quality of the paper which I have received. So this is carboxylate ion. So considering these two takes, the correct option becomes the B option. Now, question number 30, which compound cannot be oxidized by acidified potassium dichromate solution but does react with sodium metal? Okay, we need to look at the given options. The B option contains a ketone. This ketone does not react with metal. It does not react with metal. So no reaction with sodium metal. So B is incorrect. C option says it is an alcohol. So alcohol can react with the metal, sodium metal, and it can also be oxidized. So both reactions are possible in C option. So that's why C is incorrect. We need to find which cannot be. D says it is an alcohol, and we know this carbon is bonded with R alkyl group over here and another alkyl group over here, which means this is a secondary alcohol. So secondary alcohol can be oxidized by the potassium dichromate to convert into the ketone. So it can be oxidized by potassium dichromate. So this is not the correct option. The A option is basically a tertiary alcohol. This is a tertiary alcohol in which OH part is there, which can react with sodium metal, but it cannot be oxidized by the potassium dichromate. K2CO27 cannot react over here because tertiary alcohol cannot be oxidized by potassium dichromate. So that is why the correct option becomes the A option. Now question number 31. Butane 2-on reacts with alkaline I2 and excess of dilute sulfuric acid is then added to the reaction mixture. The organic product of this reaction mixture sequence are triiodomethane and the product M. What is product M? Okay, so here it is the type of the reaction which we call it as the triiodomethane reaction, or where we find the formation of the yellow PPT. We call it as Iodoform test. For this reaction to occur or this test to be positive, we should have the presence of the CH3 group adjacent to the carbonyl group if it is the aldehyde or ketone compound, or we should have CH3 group bonded with the carbon which is bonded with the OH. in case of the alcohol. So since it is butane 2 on, which means carbon must have CH3 group here. So this is butane 2 on. Now, if we look into the literature, for which I will show you my notes of ES chemistry, this is the topic under the triiodoform or triiodoform reaction or test, where we find that the CH3 group, this CH3 group is basically converted into the CI3. This is a triiodomethane. This is a triiodomethane. So this will be the one product. Whereas the other part, this C bonded with the OH will convert into carbonyl, since we have the butanon, which is basically a ketone. So we already have this part, but this part is basically converted into the carboxylate ion part. This is carboxylate ion, and this is happening in the presence of the OH negative coming from the alkaline solution of NaOH, as already mentioned in the reaction. So this NaOH is providing the hydroxide ion, which converts this carboxylate part, this carbonyl part, into the carboxylate ion part. So these three carbon atoms are maintained and they are converted into the carboxylate ion part. If we look in our question, it says that the reaction was then reacted with an excess of the dilute sulfuric acid. So if it is the butanon over here, so one of the carbon, this CH3 group will be split off from here to form the CHI3, which is a triiodomethane. Okay, this is formed here, but these three carbon atoms will then become a part of the initially propanoate ion. They will first convert into the propanoate ion because of the presence of the alkaline solution, but later with the dilute sulfuric acid, this will convert this propanoate ion into the propanoic acid. So you will get propanoic acid as a product M. This is a product M, propanoic acid. It is all because of the presence of the dilute sulfuric acid. If it was not used here, then the product M would definitely have been propanoid ion. So that's why the correct option becomes the option D. Now question number 32. 4 reagents are listed, number 1, 2, 3, 4. Which reagents, when added to ethanol, will rapidly produce a gas that turns blue litmus red? So we need to look into the reaction which is rapid, which means we need very mild conditions for reaction to occur at. Also, the reaction should produce the acidic gas because it turns blue litmus red. So acidic gas must be produced. Okay, for this purpose, we need to look into literature, and we have to see all of these reactions reacting with the ethanol. So for this purpose, I will show my notes. Okay, now in this chapter of halogen compounds, the formation of the halogen by reaction with alcohol includes reaction with HX, with that in our case is HCl. So reaction with HCl with alcohol does not produce any of the acidic acid. Instead, it only produces the water. So it is not the relevant. It is not a correct part. So with HCl, it does not produce the acetic gas. So it is excluded. Now the reaction with KCl in the presence of the sulfuric acid, or sorry, in the presence of aqueous, it is basically not as such mentioned here, since there is no formation of the acetic gas here in this case as well. So no acetyl gas is formed when there is a reaction with the aqueous KCl, and that does also mean it would also require a high temperature to occur. So it is also not included. Now the third part is liquid SOCl2 reaction with the alcohol. SOCl2 is here and it requires only warm temperature. That means only a slight temperature is sufficient, and that produces the HCl gas. So it is the acidic gas. So yes, SOCl2 can produce this acetic gas in a mild position, in a mild condition. And at the fourth point is solid PCl5. So reaction with the solid PCl5 is here, and this occurs at a room temperature, or you can also say warm, and it also produces the HCl gas here. So yeah, this is also the correct statement. It is also the correct reaction. Reaction with the PCl5 is also correct. So option 3 and 4 are correct. That means the correct answer becomes the option D. D is the correct answer. Now question number 33. 4 drops of 1 chlorbutane, 1 bromobutane, and 1 iodomethane are put separately into 3 test tubes containing 1 cm cube of aqueous silver nitrate at this temperature. Hydrolysis occurs. This is the equation. And R is C4H9. This is C4H9, which means butyl, and X represents a halogen atom. The rate of formation of cloudiness in the test tube is in the order of RCl is less than RPF, which is less than RI, which means RI gives the fastest rate of reaction. There is a fastest rate of reaction in case of Ri, and there is a slowest rate of reaction in case of the RCl. The slowest is in RCl. Now, what's the reason for this? So we know that to have a reaction, there must be a bond breaking between Rx. Only then X could combine with silver ions to form the AgX. So the theory behind this is the ability to break down this Rx bond. So this Rx bond depends upon the bond energy. So if the bond energy is smaller, then Rx bond will be easily broken off. So going down the group, the Rx bond decreases, or the bond energy of the Rx decreases going down the group. The reason is that the size of the halogen atom increases as we move down the group. The size increases as we move down the group. So this increase in size has lesser overlapping of the orbitals of the carbon of the alkyl group and the atom of the iodine. So that's why the bond energy decreases. This is basically a single covalent bond in Rx. There is a single covalent bond, and that depends upon the degree or extent of overlapping of the orbitals of the atom. So size of the halogen atom increases down the group, so does the uh, uh, strength of the bond decreases. So that's why A is the correct option. Now question number 37. Alkene S has a molecular formula C4H10, which is basically a butane. Then S reacts with chlorine in the presence of sunlight to produce only 2 different monocular alkenes. This is the molecular formula of those monocular alkenes. They then reacted with hot ethanolic QH to produce alkene. And when this alkene is treated with concentrated KMnO4, we should get these products. So we need to find which is the actual structure of the C4H10, which will produce the right compounds after these reactions. Before going into the detail and solving this question, I would like to share my resource pack with you. This is my resource pack of all the 3 levels, A2 chemistry, AS, and IGCSE chemistry. If you are currently doing AS level chemistry and you want to get resource pack, or you want to get registered for online classes, you can reach me out. We provide the resource pack to all the registered students. For example, if I select any one chapter, for example, if I take the chemical energetics chapter, it will include 4 subfolders. The first subfolder contains the recorded lessons, and these are all the recorded lessons which I have been teaching in my academy. And we do teach on these smart interactive screens, which you can see on the screen. Started. This is how. Sorry for the inconvenience. This is how we teach on the smart interactive screens. Unstable is related with the like this chemical energy. So all the lectures are being recorded on these large size smart screens. The second folder contains lecture notes, or you can say the revision notes. Uh, it contains all the provide resource material of that particular chapter, and you can read these notes for all the chapters and get prepared for the exams as fast as you can. So these are my notes of the whole AS chemistry, and this is just one chapter. So this folder will contain all the lecture notes of particular chapters. After this, you can find the topical worksheets. In the next folder, topical worksheet contains the P1 worksheet, P2 worksheet, and the solved P1 worksheet. If I open the solved P1 worksheet, you'll find the solved questions which require the numerical based questions or those which require calculations. So I have already calculated the answers by proper solutions, by proper working of all those relevant questions. So here's the PDF file which you can easily get an access of. Okay. So here in this file, you can find the solved questions of the chapter of chemical energetics, and the questions are starting from 2012. So all the relevant calculation-based questions can be seen here to be completely solved. And then the next folder is based on the tests which are frequently taken after every chapter. So this gives the progress of the students who are studying online or those who are studying in person in the academy. So you can have an access to this whole resource pack of the AS level or A2 or IGCSE depending on your demand. So you can reach me out on my WhatsApp number, as you can see on this comment section, description, and on my profile of the YouTube, or you can reach me out on my Instagram and Facebook page. All right, now let's get back to the question. So here we first consider the structure of C4H10 to be like this. There is a straight chain of the carbon atom, and then we have a reaction with the chlorine in the presence of the sunlight to produce monochloroalkene, which means we should only substitute one chlorine atom. So I can have two possibilities here. I can either put chlorine on the first carbon atom, or I could have the chlorine on the second carbon atom like this. So these are the two possibilities. Now, when these two compounds could be formed, we need to react with the hot ethanolic KOH. So what's the purpose of this? It will eliminate the H and chlorine. Both are eliminated from here, which means it is elimination reactions. So HCl will be removed from the compound. So if the reaction is being carried out in the presence of the KOH and hot ethanol, so elimination reaction will be carried out. Now I have two possibilities. This is possibility one, and this is the second possibility. From the first compound, the hydrogen will be eliminated from the adjacent to the carbon containing chlorine. So chlorine will be removed from here and hydrogen will be removed from here. And in the second case, the chlorine will be removed from here and the hydrogen could be removed from the could be removed from this carbon, or it could also be removed from this carbon, which means there are two more possibilities in the second compound. I will first draw the structure of the first the structure of the alkene coming from the compound 1. The structure of the compound coming from the compound 1 will be like this. There will be carbon, double bond carbon between first and second carbon, and then third carbon, fourth carbon. Whereas in case of the second compound, I will have two possibilities. The possibility I will name it as 3, and another possibility will be, I will just naming them, it is 4. Okay, so in third possibility, the hydrogen is removed from first carbon and chlorine from the second. So it will be like this: carbon, double bond, carbon, and then carbon and carbon. It is similar to this one. They both are same. But the other one, in which the hydrogen will be removed from the third carbon when moving from left to right. Okay, when hydrogen is removed from the third carbon, so the type of the alkene would be like this. There will be first carbon with single bond, and then second carbon with double bond, and this next carbon, since the hydrogen has been removed from here and chlorine from here, and then carbon. Now this one is different from the previous structure. Okay, it means that we are now have to react these compounds with the hot concentrated they are further treated with a hot concentrated acidified KMnO4. The purpose of this is to break down alkene. It will break down the alkene from the carbon-carbon double bond and produce either the aldehydes or ketones or carboxylic acid compounds. So I just go through the reaction between the black carbon, the black structure, and the red one. I will need some more space. So if the structure is of the one representative in black color, and KMnO4, hot concentrated KMnO4 is treated on this compound, it will be breaking down this compound from here, and as a result of this, the left carbon will convert into the methanoic acid. It will be HCOOH. This will be the methanoic acid, and the right portion will convert into the aldehyde first, which is propanol, and that propanol will convert into the propanoic acid. So it means that we should have one compound containing methanoic acid and the other one should containing propanoic acid. Here, but these statements say they both produce the same alkene T and no other organic products. Okay, the thing is that we should consider same alkene T and no other organic products. But if you look at here, you can see that these two are definitely they were same. These two were the same alkene, but not this one. This was not the same alkene as compared to this one. That's why the alkenes are not same. So this cannot be the right structure of the butane. Butane, which we assume to be like this, C4H10 having straight chain structure, that is incorrect. This is not the right structure because that has produced two different types of the alkene products, because these alkenes would further react with the hot concentrated acidified KMnO4. So we now go back to the first step in which we were supposed to consider the structure of the butane. Now I'm going to draw its isomer in the second assumption. having the same molecular formula. So I would simply rub this off from here to make the space for this compound. Now, now this time I will consider that the structure of the butane is a branch structure. It shall be looking like this. So it will be looking like this, having 4 carbon atom, but this is branch chain. Now when this reaction, it is reactive with the chlorine, Cl2, then we can have chlorine uh, position on either on the central carbon atom, this one, or it could be placed in any one of these three. These are equal positions over here. These are all terminal carbon atoms, but this C central one is a central carbon. So we could have only two different possibilities of the monochloroalkenes. We can get this type of the structure of monochloroalkene having chlorine on the central carbon atom, or we could have the chlorine bonded to any one of these three terminal carbon atoms like this. So chlorine is bonded over here. Now the next part was the reaction of this compound with the hot ethanolic KOH. When they will react with hot ethanolic KOH, they will basically convert these structures into the alkenes. So in first structure, this chlorine will be removed from here and the hydrogen will be removed from the carbon adjacent to this central carbon. It could be this carbon, this, or this. So if I remove hydrogen from here, then the structure will look like this: carbon, carbon, double bond carbon, and then carbon. This carbon, I have this structure. So this is one structure. Now for this case, I will remove chlorine from here and hydrogen from the adjacent carbon. The adjacent carbon is only this one. It has one hydrogen atom bonded here. So the structure would look like this: carbon, carbon, one carbon above, and then double bond between these two carbon atoms. Okay, now you can clearly see that these are exactly same alkene structures. They are no differences. In the first case, I removed a hydrogen from the terminal carbon. In the second case, I removed the hydrogen from the central carbon. So both have produced exactly the same alkenes. Now this part has been now verified that same alkenes would be produced. The next part is that it has to be treated with a hot concentrated acidified KMnO4. So when these two, or you can say the similar compound will be treated, they will be bond breaking over here. And as a result of this carbon will convert into the methanoic acid. It will be this compound, methanoic acid, and this side will become a ketone because the oxygen must come over here on this double bond. So it will look like this: carbon, carbon, this carbon, and the bond. This is ketone. So a ketone is produced here. Now, what about the methanoic acid? The methanoic acid would further be oxidized because of it can be easily decomposed using the same acidified KMnO4. When it reacts with methanoic acid, it produces a carbon dioxide plus water. So methanoic acid further reacted with hot concentrated acidified KMnO4. So the products which we shall get must be carbon dioxide plus water and a ketone. This is propanol over here. So we can see the options here. The first option says CO2, that's right, but carboxylic acid, propanoic acid, that is not correct. B option says carbon dioxide and then a ketone, that is correct. C says it is the methanoic acid. No, it was not methanoic, but further reacted, but ketone was right. And the last D says only ethanoic acid, that is incorrect. So only correct option is the B option. Now, question number 38. Including structural isomers and stereoisomers, how many isomers are there of C2H2Br2? Okay, so here we need to construct the structure of this compound, only then we'll be able to find out the number of isomers. So first of all, I will simply write the structure, draw the structure like this. I have Br on this carbon and another Br on this carbon, hydrogen on second carbon, hydrogen on the second carbon. So this is one structure. I will draw its structural isomer by shifting one bromine atom on the other carbon. So carbon, double bond, carbon, one bromine on right carbon, one bromine on the left carbon, hydrogen on left and hydrogen on the right. Now, this is the structural isomer of the previous one, and as well as this is basically a cis form of the isomer, since we have to take into account the stereoisomers as well. So this is a cis form, and now its transform will look like this. Bromine on one carbon on upside, hydrogen upside on the other carbon, hydrogen down, and then bromine down. Now this is the transform of each other. Oh, this is the other isomer. Now in this way, I have now one structure, this is second, and this is third. These two were basically the structural isomers of each other, and at the same time it was also the cis. So I will consider both the points here. It is the cis form and the structural isomer. So in total we have three structures over here. That's why the correct answer becomes the option B. Now question number 39. Which compound exhibits stereoisomerism? All right, here we have to find out the stereoisomerism, which includes two types, the cis trans, and the other one is the optical isomerism. The cis trans and optical both must be identified in these compounds. So for this purpose, we do require to draw their structures. So 1,1-dichloropropene. So the first structure would be look like this, carbon, carbon, carbon. And on the first carbon, we have two chlorine atoms, which I'm just indicating like this. Chlorine on the first carbon, two chlorine atoms on the first carbon, and then the double bond. It would come over here. Now, if we look at this structure, we should see cis trans, but there is no cis trans since both the chlorine atoms are present on carbon number 1. So that's the reason that it does not show cis trans. And about the optical isomer, there is no one single carbon which is a chiral carbon having 4 different groups attached on it. So no stereoisomerism can be seen here. Now the second compound, for this purpose, I will draw a structure over here. It says 2,3-dichloropropene, so carbon, carbon, carbon. And then on position number 2, we have chlorine, and position number 3 have chlorine. And then a double bond must be present on over here, because we count the carbon atom from the position of the double bond. So it is carbon 1, this is 2, this is 3. 1, 2, and 3. So since the chlorine atoms are present on second and third, double bond between 1 and second. Now can we see any cis trans here? So no, we do not see cis trans here because the first carbon has hydrogen atoms above and below here. So because of similar atoms above and below, it cannot show cis trans, and there is no optical isomer. This carbon is not a chiral carbon. It is not chiral carbon because it has 3 hydrogen atoms attached on it. So it is not chiral. Now the option C. The option C would have structure like this. And it is a propane. It is propane. It is not propene. Instead, it is a propane. So the structure would look like this. 1 and 2 have chlorine atoms on it. Now, if we look at here closely, then carbon number second, this second carbon has 4 different atoms on it. I can simply label them. We have the methyl group over here, a chlorine atom over here, and this whole group, which includes 2 more hydrogen atoms, this whole group on this side, and a hydrogen atom below it. So this carbon is basically a chiral carbon. So it does exhibit the stereoisomerism. And at the last, we have the D option. So for D option, I will draw a structure over here. Again, it's a propane, so 3 carbon atoms like this. And on position number 1, we have chlorine atom, and position number 3 has a chlorine atom. No, there is no cis trans because there is no double bond, and as well as there is no chiral carbon here, since the left carbon has 2 hydrogen atoms on it. Similarly, the right carbon has 2 hydrogen atoms on it, and the center has 2 hydrogen atoms on it, so no chiral carbon. So that's why the correct option becomes the C option. Now, the last question of this paper, the mass spectrum of CH3Cl shows a molecular ion peak M plus at the Me value of 50. With a relative abundance of 18%. Other peaks are present in the mass spectrum, but is seen in the mass spectrum at the Me value of 52. All right, so here we are supposed to find the Me, the mass spectrum at the Me of 52. So basically, the compound is CH3Cl, which contains 1 chlorine atom. The first peak is the molecular ion peak represented here, and the other peak is at 52. And if we compare 50 with 52, it means this is, if it is M plus peak, then it is definitely M plus 2 peak. So if there is a chlorine atom, then M plus peak is basically represented by chlorine 35, and the M plus 2 peak is represented by chlorine 37 isotope. So the 2 isotopes of chlorine are there, chlorine 35 and 37. You can see all of this information from the notes, which I can show you. These are my AS chemistry notes of analytical chemistry, and you can see that the M plus 2 and M plus 4 peak. So here we have 2 peaks of chlorine only, chlorine 35 and chlorine 37. The chlorine 35 is present by 25% and chlorine 37 is present by 25%. And here is the representation of that. We have the M plus peak, M plus 2 peak. The M plus peak for the compound 2-chloropropane and M plus 2 peak for similar compound at 65. The value is at 65 for, the values are mentioned here for the actual compound. So if the actual compound is C2-chloropropane, its value would lie over here. And another example for this compound, it is 78 and 80. Yeah. This value, the larger peak represents 78 of chlorine 35, and the 80 is represented by chlorine 37 for 2-chloropropane compound. Now the ratio between these two compounds taken as 1 ratio 3, or you can say 3:1, since they are present by this value. So if you take a difference, if you take the ratio, it will be 3:1 for chlorine 35 and chlorine 37. Okay, and the simpler version of the same chlorine based compound is over here. This is 3, this is 1, 3:1 for compounds containing only one chlorine atom. Now going back to the question, if the chlorine 35 is 50, chlorine 37 is M plus 2 peak, we can take their ratios along with their percentage values, which means this M plus peak was given M plus peak ratio M plus 2 peak. The M plus peak had the percentage of 18%, and we are supposed to find the percentage for the M plus 2p, which is X. And we already familiar that M plus p is basically chlorine 35 and M plus 2 is chlorine 37. So the ratio in the mass spectrum for chlorine 35 is 3, and the ratio for chlorine 37 is 1. The reason was that chlorine 35 has a percentage of 75% abundance in nature, and chlorine 37 has a relative abundance of 25%. So if we divide 25 over here and 25 over here, you get 3:1. So that's why I have written 3:1. Now you just need to cross multiply. So the X will become 18 over 3, and this will give you 6. So 6% is the peak with relative abundance. 6% is the relative abundance of M plus 2 peak. So just by doing this mole ratio, we have calculated the percentage abundance of the M plus 2 peak. So that's how this last question has been solved. So students, I have solved this paper of 2025 May-June, paper 1, second variant. I will upload this other variants of this May-June 2025 paper 1 in real soon. Also, I will be uploading all the paper 2, paper 4 of May-June 2025 very soon. So do subscribe my channel, like this video, and share with other students in your circle. Till then, take care and bye-bye everyone. And if anyone needs online tuition, he or she can reach me out for the online classes in group form, in group classes, or one-to-one as well. Okay, bye everyone.